Hello students, in this video we are going to study about methods of separation. So in previous video that we did in chemistry, we learned that in order to get a pure substance, the first step is to separate the substance if it is in a mixture. So here in the last video we learned that there are different methods such as filtration, crystallization, evaporation and etc. And we also learned that there are the other methods that we are going to, which we will be learning in this video, right? So in the last video we learned filtration can be used to separate an insoluble solid in a solution, in a liquid. For example, if sand is mixed with water, you can separate sand from water using the method of filtration. You keep the filter funnel, filter paper, then the beaker, and you put the sand and the water mixture onto it. Sand will remain, water will flow down. So that is filtration. And then we also learnt about crystallization. Crystallization is used to separate solids that has a difference that has a difference in the rate of dissolving in different temperatures. Then we also studied about evaporation, that is for substance such as salt, which does not, or which shows less differences when it comes to the changes in temperature when it dissolves. So in that case we can use the method of crystallization, evaporation, to separate salt from its salt solution, right? So in this video we are going to study separating mixtures of two solids. Now first one, sand and salt. Now when it comes to sand and salt, sand of course does not dissolve in water, salt dissolves in water. So how do we separate sand from salt? Very simple. So you have sand and salt mixture in a beaker. So here you have sand, because that doesn't spread. So okay, let's have just the sand and salt mixture first. In a petri dish you have sand and salt. So we need to separate sand from salt in this mixture. How do we do that? First we add some water. Then what happens when we add water? Salt dissolves, sand does not dissolve. So then what do we do? Once you get this, salt dissolved and sand does not dissolve, so sand will sediment at the bottom, salt will form this salt solution in water. Then what happens? You can then instead of without decanting is also fine, but then again we will have to do filtration. So we do filtration for this. Then you put the filter paper, then you pour this mixture into this. So when you pour the mixture into this, sand will remain on the filter paper, salt solution will slowly drip down. So here you get salt solution, here you get sand. So you can wash it off with distilled water, get the sand, and wash it off and dry it out and get the sand, dried sand. And this one of course we can take it and then we can heat it. When you heat it, water evaporates. Once the water evaporates, salt will salt crystals will form at the bottom. So here we have combined a method of filtration and evaporation to separate a mixture of sand and salt. Right, now this is pretty easy, this is understandable. Now if you look at this one, the second case, where you have sugar and salt, both of them are soluble in water. So what do we do? Since both of them are soluble, if you put water, they both will dissolve and you won't be able to separate it. So for that we have to find a substance that would dissolve just one of these, either salt or sugar. So when it comes to salt and sugar, it's very common that we use ethanol. So when we dissolve, instead of using water, you have this salt and sugar mixture over here. So what we do is, instead of adding water, we add ethanol. Since ethanol is flammable, we have to do it in water bath. So here you add ethanol. Salt will not dissolve in ethanol. Sugar will dissolve in ethanol. So in that way you can separate the sugar, because only one substance dissolves. So you have to do it under the water bath, because ethanol is flammable. So you get sugar dissolving in ethanol, salt will not dissolve, therefore you can separate sugar from salt in this case. Right. Now let's move on to something else. This is another method of separation. We call this as simple distillation. So when it comes to simple distillation, this is used to obtain a solvent from a solution. Now let's say, for example, in a simple distillation, the apparatus look like this. So you have this big flask over here. This is where you put the solution. So let's say we put the salt water over here. This is a solution of salt and water. So you have this simple distillation apparatus. This is closed. So from here you have this tube coming down, and this is open to a beaker that you keep from outside. So in this place you have a condenser which is used to condense the water vapor that comes in. Right. So this condenser is filled with water running through it. Here water goes in, let's say water in, and here water goes out, let's say water out. Right. Now what happens in this setup is, so this is used, let's say this is used to separate or obtain a solvent from a solution. So in salt solution, I have written salt water, that is a salt solution. So in a salt solution, salt is the solute, water is the solvent. So we have to, now we know how to separate salt from water, that is by using the method of evaporation. Water will evaporate, salt will remain, so you can get the salt crystals out. Now let's see how we get the water leaving the salt behind. So we have to get the pure water. Now for example, in some Middle Eastern countries, this is how they get distilled water for various purpose. So they're not concerned about salt, they are concerned about pure water or distilled water. So how do we extract water from this either sea water or whatever the salt water that we have? Right. Now in this case you have this salt water solution. So what we do is heat it. When you heat the flask, water vapor comes out, salt doesn't come, water vapor comes and it goes through this. Once it goes through that, here you have a condenser which is helping in condensing this water vapor that comes out. So here you have water that goes into the condenser, so it circulates, therefore it gives a cool surface here which facilitates condensation process of this water vapor that is coming out. So here it gradually, now this water, once it helps this water vapor to condense, it gets heated, therefore you have to continuously send water through this and get the water, heated water out from here. Then what happens, this water vapor goes through this part, loses its energy, becomes cool, condenses, becomes liquid, and then you can collect distilled water in this container or the beaker, distilled water. So this process is called simple distillation. So this simple distillation is used to obtain solvent from its solution. So once again, you have the solution over here. You heat the solution. So what happens when you heat the solution is the solvent evaporates. Now in this case the water evaporates and goes through this pipe. It cannot go out, it's sealed, so it goes through this condensing tube. Then what happens? The condensing tube is wrapped with the condenser, through which the water, cool water goes in and hot water comes out through another part. So during that period, or during this process, what happens is the water vapor that comes from here, from the solution, will go through this, loses heat energy, because this one is continuously circulating. This is external water that is supplied. So this water that comes through this, the water vapor condenses here, form droplets of water, and then finally will be collected at the end in a beaker or whatever the container that we keep. So here we get distilled water, that is pure water molecules. Right, so this is what we call as simple distillation. Right, now we did this and we did this. Now let's say fractional distillation. There is something called fractional distillation. So by the word itself you can say fractional distillation, that is to separate mixture of liquids from each other. Now in this case we have just one solution, we extract the solvent. When it comes to simple distillation, process is very simple, even the apparatus and everything is very simple. Now when it comes to fractional distillation, there is something added to this so that you can separate the mixtures of liquids from each other. Now for example, let's say we have, right, I shall erase this and draw the setup for fractional distillation. Right, so even in fractional distillation you have this flask where you have the mixture, liquid mixture, let's say mixture of liquids. Then it is connected to a fractionating column. This fractionating column contains glass beads. It contains, or you can say fractionating column with glass beads. So it's like you have some glass beads over here. This diagram is clearly mentioned in the book, and then this is also given a space to insert the thermometer here. So you have the thermometer over here. Thermometer. Right, now what happens is, here you have, from here again you have this setup like in the previous one where we had for the simple distillation process. We have this condenser over here and the beaker at the bottom. Now let's say this is a mixture of ethanol and water. So this is a mixture of ethanol and water. So we know the boiling points of ethanol and water. This distillation process, fractional distillation process, actually uses the concept of different boiling points. Since these different liquids have different boiling points, this fractional distillation is making use of that concept to do this distillation process. So here ethanol's boiling point is, let's say, 78 degrees Celsius. Water boils at, everybody knows, it's 100 degrees Celsius. So these are its boiling points. So what happens is, when you heat this, pay attention, when you heat this flask with the mixture of liquids, in this case let's consider ethanol and water, then you heat it, what happens, certain particles from the mixture will evaporate, right? So it contains both ethanol vapor plus water vapor. We cannot say just the ethanol, because evaporation is a process that can happen at any temperature. Boiling is the only thing that happens at the boiling point. So here when you heat this, okay, when it reaches fairly, like let's say thermometer is over here 78 degrees Celsius, around 78 degrees Celsius, most of the ethanol will evaporate. Now this is the mixture. So the ethanol will evaporate and it goes through this. Then what happens to water? Certainly water particles also would have evaporated, because evaporation can happen at any temperature. So water also would have evaporated. So you get water plus, in this fractionating column you will have a mixture of ethanol and water, both their vapor will be present here. So what happens when it gradually rises? Now once all the ethanol is evaporated here, the thermometer reading will rise to 79 degrees Celsius, let's say. Now when it rises, we know that all the ethanol, since ethanol has passed its boiling point, all the ethanol from this would have evaporated. So what we can do is, we can stop heating after that, because we don't want to heat the water. So now the vapor that comes here, what happens to this? During, now let's say during 78 degrees Celsius, during its boiling point, this keeps on, you keep on heating over here, then the ethanol vapor and water vapor will be collected here. So what we have here is, this is a fractionating column. So here we have glass beads. So what is the purpose of having glass beads is, now these water and ethanol vapor goes here, they touch the surface of the glass beads. Then what happens when they touch the surface of the glass beads? The water vapor will lose energy and it will condense. It will condense and it will drip down. So water vapor will condense and drip down. So you get the water vapor back in the form of liquid back into this flask. Only the ethanol will remain. So once all this water vapor condenses and it drips off until it reaches 78 degrees. So when it is 78 degrees, what happens? Only the ethanol vapor can remain here. Water will drip down. So once all the ethanol from here is evaporated, you can see the thermometer reading will increase. That is why we insert a thermometer. Thermometer reading will gradually start to increase from 78, let's say 79. So then at that point you can stop heating, because then we know that all the ethanol vapor is here. So once it is here, it won't remain here, it will pass through this, because this is the only pathway that it has, because it cannot come down. So this is the only pathway it has, so it goes through this. Again what happens, similar to what happened in the previous one where I discussed about simple distillation. I hope you remember, right? So here it goes through this. You have this distillation. You have water here. So what happens? Water goes in, that is to cool down, and water that comes out, that is the hot water that comes out. So here this is the condenser. Let's write it. Condenser. So in this case, ethanol vapor gradually goes through this. The condenser will do its function. So water that goes through this will circulate around this condenser, and then the ethanol will cool down, form droplets of ethanol, and you can collect ethanol in this beaker. Right, students? So Now you can see all the ethanol from this mixture of water and ethanol is collected here. So the water is left over here, ethanol is left over here. So now we should understand that this fractional distillation, simple distillation, we know that is used to separate the solvent from the solution. Fractional distillation, that is used to separate a mixture of liquids from each other. Now how it happens is based on their boiling points. The lowest boiling point, whichever the substance that has the lowest boiling point will evaporate. I mean, the others also will evaporate, but that is the one you can collect first with the lowest boiling point. So at that point you know, okay, if the temperature starts to increase, that means all the substances that had, for example, let's say XYZ, X has the lowest. So if at its boiling point, this will remain constant. Once all the X is boiled and evaporated, then its boiling point will start to increase. So at that time, you know, whatever you collect will be that particular substance X. So in this case, ethanol and water, 78 degrees and 100 degrees Celsius. We don't go to 100 degrees Celsius. At 78 we do this. Once it increases to 79, we know that the ethanol has evaporated, so we stop heating and get the ethanol in this beaker. Right now there are some industries that make use of this fractional distillation process. For example, petroleum industry make use of this process. So in petroleum industry, what they do is they take the crude oil, they have to refine it, and they get the petrol out of it, petrol and the other kinds of compounds, substances out by using fractional distillation method. They have huge, unlike this one, they have the size of the fractionating columns are very huge in those industries. Those pictures are given in your textbooks, you can refer those. Then we also have ethanol producing industries, because ethanol is usually produced by the process of fermentation. So we have other substances which are used in this fermentation process. So in order to get pure ethanol free from the other substances that we use to do fermentation, this process of fractional distillation is again made use there. Then we also can get gas from air, different gases from air is also obtained through fractional distillation process. So in that case, what is done is, gas is first cooled down, it's liquefied. So once we get the liquid gas, using this process again, how I explained, one by one gases can be extracted using fractional distillation process. Right, so far from the previous video and from this video, we learned different methods of separation. So separating the substance is the basics to get the pure substance first. So first we have to separate. So different methods we learned. One is filtration, like I told you at the beginning of the video. Sorry, we learned filtration, then we also learned crystallization. Sorry, the example that I gave you for crystallization is copper sulfate. So copper sulfate, you first heat it, then you get concentrated solution of copper sulfate, then you keep on testing that on a tile, in which you can see whether the crystal forms instantly, because it shows a difference when the temperature changes. So you can test it on a tile and see whether it crystallizes quickly, and then keep on heating, and at some point you can get the copper sulfate crystals out through the process of crystallization. Then we also learnt about evaporation, that is usually for substances like salt. Then in this video we learned separating mixtures of two solids, simple distillation and fractional distillation. In the next video we are going to learn about paper chromatography. Right, I'll see you in the next video, students.